So, hello everybody, and thank you so much for coming. My name is Nitay Milner, and as a product manager at Epsagon, what I do is help DevOps and developers monitor and troubleshoot their cloud-native environments. I bet you guys know how production issues can have a huge business impact and cost valuable engineering time. Well, what I do for a living is help companies solve and even prevent those production-related accidents. In today's session, I'm going to show you how to reduce time on production issues by understanding major recent use trends that have impacted the way we should monitor our digital systems. So the rise of microservices architecture and moving to the cloud has a huge impact on how we build, deliver, monitor, and troubleshoot our modern cloud environments. From an on-prem, monolithic, single source of truth environment, we moved into a dynamic, always changing, distributed environment. And if that's not enough, digital experiences had become a top priority to our customers, especially in the age of COVID-19. We all know that not providing an always available millisecond response service can cost us in losing our customers to our competitors. And this catalyzes companies' digital transformation and makes monitoring, especially customer-related monitoring, extremely critical to our business. So microservices and moving to the cloud can really help us become more agile, more flexible. It can help us gain more development velocity and focus on what's really important, focus on our business value. So we understand that microservices and moving to the cloud is good, but it doesn't come without a price. Microservices are extremely complex. And in distributed systems that are built from multiple different services, it's really hard to understand where the problem is originating from. In monolithic environments, using just a stack trace would probably give us an immediate answer on where the problem is, what line of code is the problem coming from. But in distributed systems, it's different. Getting to the original root cause can be pretty hard to obtain. There's a logic shift from the code within a service to the cause between microservices. And adding on that, we know that there are thousands of containers in production that behave differently. And the fact that cloud service APIs could be really hard to troubleshoot. So now that we understand the main challenges we face today with microservices and moving to the cloud, let's talk about how we can tackle those challenges. So observability is a new buzzword, but I don't really like buzzwords, so let's try and break it down. Traditional metric-based monitoring is about understanding the state of your system, how it behaves right now. And if there's a problem in your system, it will let you know. That's the old traditional metric-based monitoring. Observability, on the other hand, is a bit different. Observability is about debugging, troubleshooting your system. It allows you to understand ad hoc, without any predefined properties, what is wrong with your system, unlike traditional monitoring. Let's walk through an example to make things just a bit more concrete. So let's say we have a HTTP customer-facing server that we got an alert on because there's an increase in 500s. So we now need to understand what downstream servers to that HTTP server is causing the problem. And exactly what is the problem in that downstream service? Well, we need to use metrics, logs, and traces, the three pillars of observability, in order to detect and troubleshoot issues efficiently in modern cloud environments. So metrics allows us to understand what exactly happened. What happened in our system? In our case, it's an increase in 500s. That's the metrics. But we now need to understand where is it coming from. So we're going to use traces. Traces help us understand what's the origin of the problem. And in our case, let's say that there's a downstream service that's called a payment service, that the problem is originating from it. And now we need to understand why it's happening. So logs will help us figure out why it's happening in that service in a more detailed way, in a more well-defined way. Let's say in our example, there's an error thrown with an invalid coupon ID message in correlation with the 500s of the HTTP server. So we now understand where the problem is and why is it happening. Looking back real quick, metrics are the what, an increase in 500s. Traces are the where, the payment service. And logs are the why, invalid coupon ID error thrown from that service. So gaining observability using logs, metrics, and traces can really help us cope with the challenges that we just talked about regarding microservices and moving to the cloud. But the interesting thing is that observability is not only about monitoring. It's not only about alerting and troubleshooting. It's about understanding how your system really looks like from the inside. What's inside that black box? How does it behave in real time? Let's take an example of things that are not troubleshooting that we can use observability for. Introducing the engineering flywheel. Even before we write code, at the design stage, at the technical design stage, we can anticipate outcomes because we understand how our system looks like from the inside. We understand the dependencies between different services. So we can use it even before we write code. We can use observability to design better systems. At the implementation time, we can confidently commit changes because we know what will happen next. We have better understanding of our system. So we know what will happen ahead of time. And while we're building and running tests, we will catch more issues using observability even before they get to our customers. And obviously in production, we will rapidly resolve issues so our customers can go back to be happy and we can go back to develop amazing things. So what makes observability modern? Because we just talked about pretty basic observability. So what's observability 2.0? What's second generation observability? Well, as I see it, it's taking the three pillars of observability that we talked about, metrics, traces, and logs, and other sources of telemetry data, and correlating them together. Because looking at the data individually doesn't make a lot of sense. It's just noise. But when you correlate it and put it together, you get the bigger picture. You understand what impacts on what, and you can troubleshoot problems very fast and understand really how your system behaves and gain true insights about it. So Epsagon enables you to gain true observability, just like we talked about. We collect, export, and analyze traces, metrics, and logs, and correlate them, so that you can have a true understanding at any time of how your system behaves. And by the way, Epsagon is now free. We got acquired by Cisco, so you can just go to epsagon.com and sign up for free and use our product. Thank you so much, guys.